All right, hello people watching this video. We are starting a new chapter today. I just gave them back the tests. Some people did great, some people did not so great. So if you're one of those people that did not so great, it is the start of a new chapter. Here we go. We're gonna tune over a new leaf, start again, and it can only go up from here, hopefully. Right? 4.1 is operations on polynomials. Okay, the first chunk of this is a little bit tricky. Just because they'll throw a bunch of different rules at you at once. We're going to feed through that and we'll make some decisions here. And then the bottom part where you're adding stuff together, adding polynomials, etc., that one's not too bad, okay? It's kind of like the I stuff that we've been doing already, okay? But I'm going to preface this at the top of section 4.1. Anybody here taking the ACT yet? No, you have? No, you're lying. Okay, they on the ACT lots of times will embed this concept just to see if you know the difference. So they will test your knowledge of whether or not you know the difference between x squared times x to the third power and x squared cubed. X squared cubed, okay? There is a difference between those two things, and one of them you're multiplying the exponents and the other one you're adding the exponents. Do you care to take a stab at which one is which?
Okay, you're adding on the top and the other on the other.
Okay, so Josie says you're adding, so this would be x to the 5th power. The bottom one she says is x to the 6th power, all right? I'm going to show you why. When you're taking something to the 3rd power, that means you're taking it times itself 3 times, right? So this would be x squared times x squared times x squared, right? In which case you're adding all of those together and that's x to the 6th power, right? Or you can just say that these are multiplied to begin with, right? So when they're stair-step like that, when you're taking a power times another power, you multiply. When they're just two different bases like this, you are adding. Make sense? Okay, now we're going to be doing other stuff, like let's say you have, write this off to the side also, let's say you have 4x squared y cubed times, and I know that that's times because we're using just parentheses and not doing a symbol. Ahmed, are you paying attention to this? You better write this down. Let's say xy to the 4th power. Okay, and you're trying to solve that. Anybody know how to do that? Yes. Okay, so don't try to do a bunch of stuff at once, right? Just worry about the numbers first. So 4 and -2, if you multiply those together, it is -8, okay? Those are done. Now we have x's. We have 2 x's here and an x over here, which makes a total of x to the 3rd power, right? If he doesn't have an exponent, you assume that it is 1, right? Okay. And then how many y's do we have? Is it 7 or is it 12?
7.
You're sure?
Yes.
7 because you're adding. So that's how that works, okay? So don't get bogged down by trying to do more than one thing at a time. Worry about the numbers, worry about the x's, worry about the y's. All done, right? Good? Okay, let's go through and let's talk about some concepts over here off to the side. We have product of powers, quotient of powers, all that good stuff. I'm going to do some examples off to the side. So this was one that we've already done. Let's say we have x squared times x to the 4th power. What will that make? Is it 8 or 6? 6. You're adding, okay? Let's say quotient. So let's say I have x to the 4th divided by x squared. You're subtracting, okay? Which makes x squared, right? Okay? This confuses people a lot. But let me show you how this works. So she said that this was x squared. Let me do another little example real quick. And let's say instead I have x squared over x to the 5th power. Let's say I have 5 on the bottom, okay? And this is kind of confusing because you are subtracting, right? So that would be x to the 3rd, but if it helps you to think about it this way, you sure can. X squared means x times x, right? And x to the 5th means 5 of them, right? Okay? And we know that we can cancel things, right? Like this cancels and that cancels. So you will have 3 of them left, but where will they be located? On the bottom in the denominator, right? X to the 3rd power goes in the bottom. But if everything's canceled on the top, what do you put on the top? 1. You put the number 1, right? Okay? So that's how that looks. If you need to write out all the x's and cancel until you get like a little bit more familiar with it, that's fine. X squared, x to the 5th, you subtract those. There's 3 of them, but they're in the bottom. If there's nothing on the top, you put a 1. Does that make sense?
You run out of x's,
What?
Can you go back?
so after you run out of x's, it's just 1?
Yes, if it's not, yeah.
Or could you just write instead of 1, could you just write x?
No, because 1 is different than x. Because then you would be assuming that you have an x still there and you don't have any x's there. So it's just 1. What?
What about x to the negative third?
What about x to the negative third?
What about-
Yes. So that's the next thing that we're going to talk about. Okay. So, okay. All right. So we have x to the third on the bottom here. So we just did 1 over x to the third. That is the same thing as x to the negative third power, right? Okay. X to the negative third power is like 1 over x to the third, right? Okay. Let me give you another example. Let's say I have let's say I have 1 over x to the negative 7th power.
So it's 7.
X equals
X to
negative
the
7.
7.
So I move him to the top. Anytime you have a negative exponent, you move it either to the top if it's already on the bottom, or if it's already on the top, you move it to the bottom. You just switch them back and forth. This one is on the bottom, so you move it to the top. So he becomes x to the positive 7th over 1, or just x to the positive 7th, right? Okay? Confused? Are we doing okay?
Why is it positive?
When you switch them from numerator to denominator, it switches the positive and negative.
So if it's
right?
a positive and going to the negative, it'd be a negative.
Right. Okay, I'm going to do another example. Let's do one over here. So let's say I have x to the 5th on the top, and let's say I have x to the negative 3rd on the bottom. I have 2 x's. Okay, I want to first try to fix the negative exponent. So how do I get rid of this x to the negative 3rd power? Put it on top, and it becomes x to the positive 3rd power. Now he's not on the bottom anymore. But I already have an x to the 5th power on the top, right? So now I want to put those together. Does that make 15 or 8?
8.
X to the 8th power, right? Okay, and then what's on the bottom? 1, but you really don't have to write the 1 on the bottom. If it's on the bottom, you don't have to put the 1, right? Like numbers, like the number 5 is technically 5 over 1, right? But you don't have to put the 1, okay? So x to the 8th power is all that you need, right? Okay? So you want to fix exponents and then put together things that you can. Does that make sense? Okay? So those are negative exponents. You get rid of a negative exponent by either flipping it down or flipping it back up if it's already on the bottom. You just exchange the two and it makes them positive, negative, right? That's how that works, okay? All right, power of a power is like we went through and we did x squared to the 3rd power. Let's go x squared to the 4th power. Is that 6 or 8? 8. This is when you multiply, so it's x to the 8th power, okay? Now, let's do another one. Let's talk about power of a product. So let's say I have 2. Now, let's do this. Let's do 3 x cubed y to the 5th, and I'm squaring that, right? Okay. Now there's a reason why I put a number there also, because a lot of people can like remember to do this part, right? X to the 3rd squared is going to be x to the 6th, right? Okay. X to the 5th squared is going to be y to the 10th, but then they forget about this 3 and they put 3 there, right? You have to square the 3 also, right? What is 3 squared going to be? 9. So we've got to go back through, delete that, and we've got to put 9 in there, yeah? Okay? Now, if it helps you to think about it this way, right? What does it mean when we square something? We take it times itself twice, right? So if it helps you... What?
Why is there 2 power of a
Power of a power and power of a product?
Oh.
Yeah. One of them's just saying one piece, and one of them saying if you have more than one piece, it works the same way also. So if you're taking something and squaring it, you're just writing it twice. And that you can definitely see turns out to be like that, right? Okay? So there's multiple ways of thinking about this information, yeah? Okay? Now let's do power of a quotient. So let's say I have, let's say I have 2 over 5. Let's do an x on the top, a y cubed. This is the power of a quotient, yep. Y cubed, z to the 5th power, all to the, we'll do it squared again. We'll do it squared again.
Is that a 2 to the 5th?
This is a lot.
What is that, a z to the 5th?
That's a z to the 5th, yep. I'll make him a little nicer maybe. Z. There you go. There you can see him now.
Why'd you write a line?
Because I just always make my z's. Otherwise, they look like 2s. Yep.
Also that about your 7?
What? Also that about my 7s.
Okay. Makes sense.
And then if I'm writing out words, the letter A, like a tree.
Yeah.
or a squared plus b squared equals c squared, right? So if it's a letter A, like in a word, if it's the word A, it's like that. If it's a variable, it's like that.
I've never met anybody but you till right now that writes a name like that.
I do.
Do you? Yeah. I write my variable A's like this though.
Good.
And I write my
cannot be
letter
called
A's.
mentally
My word, my
insane.
A as a word or A as in like a tree
I cannot
is
be
an
called
A like that.
mentally
That's like how
insane
it's
for writing my
typed,
full
right?
words
Anywho,
I
I don't know. Just so I can distinguish between like if I'm writing like words and equations at the same time, I can distinguish whether it's a variable or a letter. Because I deal with variables all the time. What?
Sometimes I go to write an F and I write a 5.
I don't know. Anyway. And my eights, I don't know. Who else does snowman eights?
Who? What?
Snowman eights?
What?
Reese.
Oh.
Eights? Snowman eights?
No.
Yeah?
Sometimes I
It
put a line.
depends.
Because I can't make it look like this, otherwise it looks like an infinity symbol. Because
Well,
I write infinity
Does anyone
symbols all
else,
the time.
Does anyone else
Right.
put like a 7 and a line through it?
What?
7?
Yeah, I think
This
those
is fun.
sevens
This
are so
is-
pretty.
Oh, like put a line
Yeah,
on
I
it?
think that's just so pretty.
This is
It
my
just looks
picture.
like a
Anyway,
back.
I had something kind of similar like 2 years ago. Like I was like one day I woke up, I
I like
couldn't
how
write an
this
S
is
normally anymore. Like I would get halfway done, I couldn't get my hand to go any further.
Huh,
I
nice.
did like this for like 3-4 times. and I
Really?
finally
Yeah?
destroyed it.
Yeah?
Question.
You're like, you lose the muscle memory in your,
I
okay.
like lost the most.
Alright, so let's go ahead and simplify this guy. 2x over that stuff squared. We're squaring everything. Everything gets squared. So square, right?
Okay.
2 squared on the top is
4.
4. X squared
4.
just stays x squared, right? X squared. That's x to the first power to start with, okay? 5 squared on the bottom is
10.
25.
No,
25.
That-
Y to the third power squared.
What the dog doing?
Six.
Y 6. Z to the 5th squared.
Z25.
Z
Ha, ha.
10. You're multiplying. Yeah? Yeah? Okay?
I believe it.
That's the power of a quotient. All right? 0 power is saying anything, any number, any variable x to the 0 power. 17 to the 0 power. 92 to the 0 power.
It makes anything 1.
Whatever. It makes everything 1. Anything to the 0 power is 1. That's a weird thing. Okay? So anything to 0 power is 1. What? Oh, like, what are you talking about? Oh, like in the y's right here? Okay? But this is
But
like
you're
y
multiplying
to the
the
third squared, right? That's like what you're
exponent.
doing, right? You're just multiplying those. So it's not 3 squared, it's y to the third squared, right? Yeah, you're not squaring the 3, you're multiplying 3 by 2 is what you end up doing. Yeah, good question. That's a very good question. Okay? All right, let's go over here and let's answer these questions. So A, all right, so when we're looking at A, we have 3 pieces. Do you see the 3 pieces? 1, 2, 3. We have 3 bubbles. What are we doing to those things? What are they asking us to do? Multiply, because we have parentheses. Okay, now, don't try to do more than one thing at a time. Okay, worry about the numbers first. So this number is 2. This number is 3. What's this number on the third one?
1.
1. There's an understood 1 there, right? Okay, 2 times 3 times 1 is 6. Okay, now let's worry about the A's. So I'm going to get rid of those. Those are all done. 2, 3, 1 is all done. Let's worry about the A's. I have A to the negative 2 and A to the 3. We're adding those. What's negative 2 plus 3?
6.
A to the 1 or just A, right? Now the A's are done. Left I have
Squared.
B squared
C to the negative.
and C to the negative 2. That's a 2. Negative 2.
It looks like
Okay?
it's about-
Now, before we move on and say that we're done, we don't like negative exponents, okay? What is this thing as a fraction? How do I make him into a fraction now?
6ab squared.
We're going to put him over 1, and now I want to fix that C to the negative 2, so I just bump him to the bottom. He goes like this, right? Okay? So everything else stays on the top, 6ab squared, but over C to the positive 2. Does that make sense? Okay? We fix any negative exponents to get in better. I'm not going to explain this to you again second period if you're not listening now.
Actually, I know this.
Okay. All right. So answer the questions, and check your answer to make sure you know. Okay? 6ab squared over c squared. Good? Okay, now B. We have a bunch of Q's and we have a bunch of R's, and we're trying to get them to go away with each other. So I have Q's. I have 7Q on the bottom and 2 Q's on the top. If you subtract those, I will end up with 5 Q's, but where will they live? On the bottom. This is Q to the 5. Now, You could be negative q on the top. So q to the negative fifth power on the top, but we always want to make our exponents positive. So we're just going to leave them like that. Yep. Okay, now r's. We've got our r's to deal with next. We've got 4 r's on the top and 3 r's on the bottom. Again, if it helps you, make r. There's 4 r's on the top and 1, 2, 3 on the bottom. So they cancel. So what are you left with? 1 r on the top. So r to the first power or just r, and that's all we can do. Does that make sense? You're just combining stuff, okay? If it helps you to write them out and cross them out, that's fine. Yeah, because you basically go in the direction of the bigger power, okay? Now, I'm going to do one like I did over there before where we have, like, let's say, I don't know, let's say x to the negative 2 and x to the 6th power down below here, okay? How do I combine those two? Okay, so I want to move the negative to the bottom, okay? So this becomes x to the positive 2 power, right? Okay? What's left on the top? 1, right? We leave 1, okay? And then how many x's do I have on the bottom? Is it 8 or 12? 8, right? Because we're adding exponents, okay? I just made that example up. So if you have negative exponents, you take care of the negative exponents first. You move them and then you combine, right? Happy with that? Okay? This gets a little hairy when they start to combine rules, I guess, okay? All right, let's go to this last one. Woo! C. Yikes, what do we need to do first? So they're starting to combine stuff together. Like, what do we do? How do we do this? We need to cube everything. So negative 2 cubed, this guy cubed, this guy cubed. Everything gets to the 3rd power. So negative 2 cubed is negative 8. Negative 2 times negative 2 times negative 2 is negative 8. What's a to the 4th and then to the 3rd? Is that 7 or 12? 12, because you're multiplying, right? What about b squared cubed? 5 or 6?
5.
6. Because we're multiplying, right?
1 for 2.
Yep. Okay.
That's all we're
There you go. Is there anything else that we can do with that?
Wait, hang on.
Maybe move the 8 down.
Now, the 8, that's a good question. The 8 is negative, right?
There's no x.
Should we move him down to the bottom?
Yeah.
He's not an exponent, right? He's a number. You can have negative numbers, but you can't have negative exponents, right? So we want to leave him in the top, and that's a very, very good question.
That's
I'm
what
glad
I
you
had
said
for
that.
my answer, but I was just throwing it out there.
Gotcha. Yes, perfect. Okay, good.
I'm bringing Ghostbusters.
Questions about that?
No.
Okay, let's go to the next piece. These are kind of easy. These next pieces are the easy part. When they talk about degrees of polynomials, okay? Let's talk about these first. Let's say I have something that's like 3x cubed plus 7x squared minus 4x plus 1. Let's talk about that one, okay? That's a polynomial. How many pieces does he have?
4.
1, 2, 3, 4. What is his degree? What degree is that? He is a cubic function. The highest power is 3. He's a 3rd degree power, right? The highest power is 3. Good?
He has associate's degree.
So the highest power is.
Is that the
the
3rd
largest
though?
I don't know.
That's what we equate to the 3rd. What's the 7th power? That your doctorate or something?
I have
don't know.
no clue.
Anyway, whatever.
I was just throwing something out
4
there.
years, 3 degrees times 7.
I don't know. All right, now here's another example. So let's say I have 4x squared y to the 3rd plus 7x to the 3rd y to the 5th minus 8x plus 1. Let's say I have that going on. How many pieces? Hold on. How many pieces do you have? Just wait. How many pieces do you have?
1, 2, 3.
1, 2, 3, 4. Okay, now.
5.
This guy, to look at this guy's degree, you add the exponents together. So what is
It's
he?
8. It's 8.
He is 5, right? What about this one?
24.
8. This guy has
21.
1. What's this guy's degree?
0.
0. Now go with the higher one. Which one's the highest? This guy has a degree of 8.
So the degree
Okay.
is the highest.
The highest one within each term, right? Within each piece, you go with the highest exponent. Make sense? Okay? Within each piece, you go with the highest exponent.
How do we know if it's a polynomial?
How do you know whether it's a polynomial? It has to be x to some power. So we'll talk about what polynomials are and what non-polynomials are.
What's a polynomial?
So, polys
Don't
versus
polynomials-
non.
don't
Okay.
polynomials have like 4
Polynomials is x to any power. Okay? Or y's to any power. Or any combinations of xy to any power. Okay? Non-polynomials are like square roots of x's and y's, okay? They are x's to any negative exponents, like to the negative 2 power, right? I'm trying to think of other stuff. Cubic roots, any ones that say like 1 over x, any of those, right? Those are all non-polynomials, okay?
Is it x squared or any negative?
Any negative exponent. So x to the negative 14th power. That would be a non-polynomial. So polynomials versus non-polynomials, okay? So part A, is this thing a polynomial? How many pieces does he have?
2.
1, 2. Is he a polynomial?
Yes.
Yes. I'm going to say yes. He's a poly.
Nomial.
Okay. Of those 2 pieces, what is the degree of this first piece? 7. What's the degree of this guy?
5.
So what's the overall degree?
7.
7. It's the highest one, right? So yes, he's a polynomial. He is of the 7th degree. Okay. B, is he a polynomial?
No.
No. Why not?
X squared.
X, the square root of x. We can't have that. What about C? Is he a polynomial?
Yes. No. Negative.
Negative exponents, right? Can't have negative exponents.
Where you said it was
Poly and non-polynomials. Do you know why x to negative powers are non-polynomials? Right? X to the negative third, this is like 1 over x to the third. This is like 2 over x squared. You can't have an or you can't have a variable on the bottom, right? Okay? In order to be a polynomial, you can't have a variable on the bottom. Okay? Do you know what 1 over x looks like when you graph it? Those aren't polynomials. They're not curvy things. They're like the boomerangy guys, right?
Oh, then.
Yeah. We'll talk about those later on in this chapter. Okay? All right, moving on down below. These ones are going to be like really easy, really fast. This is kind of like the I stuff. Up to...
Okay, never mind.
Okay. Are we good?
Yeah.
Good? Okay. So, these guys down below here, one of them you're doing... What are you doing here? What are they asking you to do?
Good question.
Simplify, but the operation is subtraction. We're subtracting. Subtract. Okay, we're subtracting. Okay, so when you subtract, you have to be very careful. You have to do what? Subtract.
Make everything.
Distribute the negative. Distribute the negative. Everything after the negative changes sign. So we have 4x squared. This guy's just going to chill. I'm going to rewrite him. He's just going to chill out, right? He stays the same. But now we have
Negative 2x squared.
negative 2x squared minus 3x plus 1. Okay, and then are we done?
No.
No, now we have to combine like terms, right? So 4x squared and negative 2x squared will go together. 4 minus 2 is 2x squared, right? Those go together. Okay, and then we have negative 5x minus 3x. Minus 8x, yep. And then 6 and 1 becomes 7. Now are we done? Yes.
Indeed.
I had to ask, whatever. Okay. All right, now adding.
Wait, how'd you get 7?
6 and 1. Yep, we're not multiplying, we're adding. Okay. So now we're adding these guys. This is what this says. We're adding in between those two guys. And really, kind of like minus, we do have to distribute the negative, or distribute the plus sign. But this guy's just going to chill. We're going to rewrite him. Minus 7x plus 8. He's just going to chill. But when we do a positive times a negative 4x squared, what happens?
Nothing.
He stays negative 4x squared, right? What's a positive times a positive 9x?
9.
Plus 9x. What's a positive times a negative 5?
It's negative.
So this guy basically stayed the same, right? When you're adding, it's just kind of dropping the parentheses. You are distributing the positive, but he's not changing sign, okay? Now we combine stuff. So what can we combine?
6x squared minus 4x.
6x squared minus 4x squared is
2x.
2x squared because it's minus 4, right?
Oh.
Okay,
7x
so that's
plus
gone.
9x,
Negative 7x plus 9x is
2x.
plus 2x, right? And then 8 minus 5 is plus 3. Done? Yes. Isaac Mackin, did you get that written down?
Almost.
You best do that. You best do that because I'm going to go on pretty soon. Okay?
Give me there for like 5 more seconds.
Okay. So we're having to wait for you because you were being like not prompt with your...
I was being lackadaisical because I knew.
So you're waiting the whole class down. And Reese has been ready to move on for like 10 minutes now.
I've been
Okay,
lackadaisical.
so moral of the
paying
story,
attention so much.
moral of the story, pay attention so we don't have to wait for you. We're not waiting. We're not waiting. Okay?
Much that I just got
Great.
super lackadaisical.
Great. Example 4 is at the top of the second page. Flip over.
I need a nap.
And this 3x is one piece, and then we've got like a trinomial here, which is 3 pieces. We've got 1, 2, 3, okay? Now, do you see how the 3x is on the outside of the parentheses? This is like distributing, right? This times this, this times this, this times this, right? Okay? What's 3x times 2x squared? 6x to the third. What's 3x times negative 4x?
Negative 12x squared.
Negative 12x squared. 3x times 6.
18.
Plus 18x, right? Anything else we can do?
No.
Are we done?
Yes.
Yes.
Yep.
Okay? You're just distributing. Okay? Now we're going to skip the next example, and I'm going to go down to example 6, which is the last problem. Last problem. You can cross 5 out. I don't care. Okay? All right. Last problem. This first little piece in the bubble here, how many terms is that?
3, 4, 5, 4.
That looks like 3.
It's 3. This is a trinomial, which means it is 3 pieces. And this second part is a binomial.
I was gonna say die.
Is a binomial. It's 2 pieces, right? And we are having to do what to those things?
This, multiply.
How do you know you're multiplying?
Because there's nothing.
Like there's no sign there. You're just bubbles, right? They're like parentheses, okay? Now, 3 times 2 gives you 1, 2, 3, 4, 5, 6. So when we are done multiplying these, you're going to have 6 pieces before we simplify and combine like terms, but we will have 6, right? Okay, this example exactly is the reason why Mr. Arms, this is the reason why Mr. Arms does not teach you the FOIL method, right? FOIL is first, outside, inside, last, right? Except FOIL only has 4 parts, right? First, outside, inside, last. We will have 6 parts. So there's like a first, 2 outsides, like 2 middle insides, and then the last piece, right? Like there's like more than 1 middle piece, okay? So this is why it's basically FOIL, right? But he doesn't call it FOIL because there's not 4 parts to it, right? Okay, so we're just gonna do this like we would normally FOIL. You start with the n squared. What do you take n squared times first? N squared times n. So my first blank is going to be n to the 3rd power, okay? Then I take n squared times
2n squared.
2, right? And that's plus 2n squared. 2n squared. Don't forget to put your plus sign in the middle of there, right? Okay? Then my n squared is done, and I'm going to start with 4n. We take 4n times n, which is 4n squared, but don't forget the plus. So it's just 4n squared, right? Okay, then we take 4n times 2.
8n.
8n?
Yes.
And don't forget the plus. Don't forget the plus. Last thing we do is negative 6. Don't forget the negative. Negative 6 times n is minus 6n.
I got it.
And negative 6 times 2 is, and Isaac Mackin didn't get any of that because he's not paying attention. Your attention span. Your attention span. You need to work on lengthening that a little bit. Okay, great.
Have you passed the math test at all this year?
Yeah, I'm a read. No,
All right, we have 6 pieces.
Last one.
Okay, shh. Let's go. We have 6 pieces. Can we put stuff together?
No. Oh, yeah.
N to the 3rd. We can't put anything with him, so we're just going to write n to the 3rd. But we have 2n squared and 4n squared.
6n squared.
6n squared. There he is. Okay. 8n plus 2n
Minus 12.
minus 12. You got it. There he is. Okay. There he goes. Good? Yes? Happy with that?
Yeah, no, but still.
Okay. Your.
Go back to
Woo.
Yeah.
It's
It's so easy though.
Okay.
You got a lot of colors.
I do. I have lots of colors. There's lots of colors going on there. Every time I switch pieces, I do a different color. Right? That's color coded. Okay.
Wow.
All right. Moving on.
But
Your
that's
homework
it.
assignment
Oh.
looks like this. It's kind of ugly. It's got a lot of stuff. But you will only do unless you want to do some extra problems, I don't care. You will only do the odds. Yes? Okay? But there's a back side that is like, I have handwritten stuff, and you will do all of those. Okay? There's only 6 on the back side. Those are the easy problems. What?
This is just like foils.
Except the first part. Like
Yeah.
here, you're just doing stuff. Okay? So your first problem here, like number 1. You don't have this paper yet, but I'll show you. Number 1, before I do this.
6.
Okay? So, we have 4 squared times 4 to the 4th power. They both are the same.
16 and 6.
No, you don't multiply the 4's together.
Why not?
It stays 4. Like if you this was
4
x squared times x to the 4th, it would be
4 to the 8.
x to the, is it 6 or 8?
6.
6. 6, because you're adding, okay? But it's actually 4. Now, here's my question to you. 4 to the 6th power. You can actually do it in your calculator, but you don't need to. So I'm going to have you leave your answer like that. Does that make sense? Right?
Yep.
You don't have to go ahead and these top parts, like you end up with some like really huge big ones on some of the other ones. You don't actually have to go ahead and figure those out. You can just leave it the way that it is. Okay? Happy with that? All right. Odds on this page. Bye, people in the video.
Bye.